So we have a graph here, show that. Oh, we have to differentiate. So let's say y equals u over v, where u equals log x and v equals x to the power 4. So we can do a du by dx. Differential of log of x is 1 over x. And dv by dx, differential multiplied by the power and subtract 1 for the power. So dy by dx is v du, which is x to the 4 times 1 over x, subtract u dv by dx, 4x cubed log x over v squared. So here we have 1x cancel one of the x's here to give us an x cubed. Subtract 4x cubed log x over x to the 4 squared is x to the power 8. Factorize out an x cubed before we cancel it with the denominator. That's an x cubed x to the power 5. The x cubes cancel, which gives us 1 subtract 4 log x over x to the power 5. Quad error demonstrandum. That's part A done. Part B. Consider the function. So now we have a function where f of x, oh, that's the y we had before, so we've still got the same thing. And its graph y equals f of x. The graph has a horizontal tangent to point B. So a horizontal tangent, that means that we've got the graph does here, there's a horizontal tangent here. That means the gradient is 0. So for part B, f dashed of x equals 0. Therefore, f dashed of x we worked out in the previous part. Let's get rid of the fraction by multiplying by x to the power 5. So that cancels that out, and 0 times anything gives me 0. So we get 1 subtract 4 log x equals 0. Add 4 log x to both sides. So 4 log x equals 1. Divide by 4. Log x equals a quarter. And to get x to e to the power of log of x gives us x equals e to the power a quarter. And it wants the coordinates of p. So we've got the x value, now got to find the y value. So we do f of e to the quarter. We're putting e to the quarter back in the original function, which was this one. So we're log of e to the quarter, log of e to the quarter over e to the quarter to the power 4. I can take a power in front of a log, so that's a quarter log e over, multiply the powers, e to the quarter times e times 4 is e. And log of e by definition is 1, so we get a quarter divided by e over 1. Divide by a fraction, I turn it upside down and multiply. So that gives me 1 over 4e. So the coordinates it wanted are a quarter, 1 over 4e. Sorry, e to the quarter, 1 over 4e. E to the quarter, 1 over 4e from our x value and our y value. Part C, given that for double the second derivative, so we don't have to work out the second derivative, they've done it for us, that's nice of them. Show that P is a local maximum point, so then we have to substitute in. So we'll do part C, f double dashed of e to the quarter equals 20 log x subtract 9, 20 log e to the quarter subtract 9 over x to the power 6. So that's e to the quarter power of 6. Well, we can do the same thing again, take the quarter out of the front. So 20 times a quarter is 5 log e subtract 9 over e to the 6 over 4, which gives us log e is 1, so that's 5 subtract 9 over e to the simplify 3 over 2, which equals negative 4 over e to the 3 over 2, which is less than 0, therefore maximum at P. Part D. Solve f of x is greater than 0 for x is greater than 0. Well, f of x was this value, and x has got to be greater than 0, otherwise we can't put anything in. So let's find out when f of x equals 0. So let's do f of x equals 0, because unless there's an asymptote, it can't cross over the axis. That should give us an idea what it looks like. So that means that the original f of x is is log x over x to the power 4. Log of x over x to the power 4 equals 0. So we get log x equals 0 and multiply both sides by x to the power 4. So that means that x equals e to the power 0, which equals 1. So it's 0 and x equals 1. So if we look at a sketch for a graph, it wants to be greater than 0, so we don't care about anything less than 0. And it's when we make x really small, we're going to end up with x is small, so that gets really small, makes it big. And this is really negative and big, so it's really big and negative. That means it's way down here, it's tipping off the side. It comes across the x-axis when at 1. And then we've got to get to a maximum. Our maximum was here when x equals e to the power a quarter, so that's the fourth root of e, which is probably somewhere between 1 and 2. And this is our maximum height is 1 over 4e. That's quite small, so it goes up to say, looks like this, gets to maximum, then it's going to come back down. It never crossed the axis again. And this maximum here is going to be at e to the quarter 1 over 4e. And so therefore that's y equals f of x sketched based on the information we have from that one. We've sketched a graph, the value of the x-intercept we've done, approximate position of point P. So it's marked on P here. And then we've done the approximate position of that is correct.